Okay, sorry about that. Recording's on now. So Jarno proposed to the agenda reviewing the GPIO interface. So we'll get to that. Thank you for submitting the pull request. For some reason, I think a number of us saw it, but never actually merged the pull request. So my apologies, but we can discuss that here. Any other agenda items before I go through a recap of the last call and then move on to the GPIO interface? The only thing that I would add, and we'll discuss this in reading the previous notes, is there is an outstanding pull request for the proposed alternatives. I think many of you have probably seen some of these. If you've not, we can provide the pull request link here in the chat. Chris opened it up. We're looking to close that pull request out, and then I think we were trying to do it yesterday, but I think it's probably going to go a day or two longer. So I'm posting that in the chat. If you've not read that, it is what we'll be discussing a little bit more today. But that's what was presented in our last call. So any questions on that first, or I'll start going through the meetings from the notes from last week. Okay, so in short, the document was put together. It's called Alternative Solutions for WASI and WASM. It presents an alternative approach where we're proposing having a layered approach to the WASI standard. In short, have a low-level interface that is system-oriented, and then that would be based on core WebAssembly only or core WASM only, and then on top have the application level interface that would be the full component model as it is today. In other words, allow these two to proceed in parallel, and also provide a means for interoperability between the two. This is really based around some of the things that Chris started off saying about needing support for existing people built on P1, WASI Preview 1, WASI Snapshot Preview 1, sorry, and using existing runtimes. And so there's a number of folks that expressed concerns last time that needed to be supported. And while those things worked, they were limited. So there's things missing, such as threading was never officially added to P1, for example. Further, there's other things like signals that are not working. And then, for better or worse, there's no equivalent support that is ready and deployable, at least in a production capacity or even close to production capacity in WASI P2 or 0.2 onward. So that's the sort of the background of that, needing to have a path forward, support existing runtimes, and then the proposed solution was to add some layering. So lots of discussion went on there. I'm not going to read through all the discussions that's in the notes from last time. I would say some of the highlights here that happened during the discussion is there seemed to be a fair amount of agreement that something needs to be done here to support the P1 folks and support existing work. There was a lot of discussion around needing that and probably limiting that only to C and maybe C++. Luke brought up a really good point about avoiding handcrafting interfaces. That's something that was done early, and that actually causes a lot of problems, especially when you're handcrafting things in languages like C and then having to do it again in Rust and Go and whatnot. That's one of the purposes of WIT, so that we could generate those things. And so I think there's a general agreement that there needs to be some sort of IDL, WIT or otherwise, that would provide that capability, and then we can generate those and avoid that handcrafting. There was a lot of discussion about what can be done and what is already being sort of discussed and in progress around performance improvements. That was another big concern people have in the embedded space with the component model, is the overhead associated with lifting and lowering, some of the interfaces and so on and so forth. And so some of that clearly can be done with tooling. There's a lot of promising things that are being done. Luke discussed a few of those. Shared memory is one of them. There's a few others. And while that is all good, and I think we all want to see that work go ahead, the reality is that stuff isn't ready today, and we need a more pragmatic solution in the short term. And I think that's what most people kind of agreed on. The other thing that was brought up by Microsoft. Ralph from Microsoft said, "Hey, listen, we've had a lot of these kind of discussions before, and in the past they've not really gone forward. It's not because people, did it with ill intent. It's just that it kind of gets, unless there's some concrete actions to move this forward, it tends to fall in between the cracks and not get done. And so his suggestion was, let's get together a list of things that are needed, concrete list of things that are needed, and then use that to move forward. And so that's one of the two action items. So the first action item was to do the pull request and refine it and address the comments and discussions. So that's the link I sent you before. And the second is start to build that list of concrete needs. And then per Ralph's suggestion, let's start taking, choose one or two of them and get people to work on it. And if people can work on it and move it forward, that's a really good sign. If it falls and dies on the vine, then obviously, this effort could end up not being as effective as we want. And so I think we don't want that latter approach. We want to take that concrete list and start working it down. Any discussions, points, anything I missed? Any questions based on the last meeting? I know that was a fast read.
I think that pretty much covers it. My question would be, who has already seen it or read the PR and followed up the discussions?
Chris and myself certainly have. Luke has as well. I can go through it real quick on my side here. And have folks in this, that's actually a really good question. Have folks on this call, have everybody aware of that? Have you read it? Have you seen it? Do you disagree with it? Do you agree with it?
So just speak out.
Sure.
I know from yesterday's talk with the TC of Whammer that I guess at least Liang Hei should have read it. If I'm wrong, then just speak up.
Okay. Was there anything that happened in that TC call that's worth discussing in the context of this, Thomas?
No. So at the TC, just was told that the concerns are shared. Marcin brought up their need for this backward compatibility. I brought up the concerns regarding performance. Yeah, that's basically it. Nothing more to add here in this round.
Okay. Let's see. Yeah, so Chris originally proposed on this PR to close it by close of business yesterday, but I see it's not been merged. So I would encourage anybody, if you have any comments, please look at that pull request. Please provide your feedback. I think it's really important, whether you agree or disagree with it, whether you have technical points on it. Please put some notes in there so we track that. And then once we merge the document or merge the pull request, then obviously there'll be a lot more work. But I think getting everybody's input on that is going to be super helpful and crucial. I think one of the other things that was pointed out in that thread is the need to bring along some engineering resources. There's potentially a lot of work to be done, particularly around things like the WASI SDK, WASI libc tooling, and whatnot. If the embedded team needs these things, a lot of that tooling has not received as much engineering love as others, mostly because many folks are not working, at least of the active work in the component models being done on Rust and Go and some of the other languages. C has not been as active. And so if we want that kind of support, there's going to need to be, there's a need for us to step up in that regard. And so that's something that we're looking for participants on, looking for help on, and for people's input. So. Okay, so that's that. That's the proposal. I think let's jump to, unless there's any other issues related to this, let's jump to Yarno and talk about your GPIO interface. And then in the last bit of the meeting, if you have a few minutes, we can talk about potential things to that per the list I talked about. You know, what are the list of issues we need to get sorted and solve? We can do that towards the end of this call. So, Jarno, over to you.
Hello, good morning. Thank you. So I made a pull request with a discussion about the WASI GPIO API, and I included a link to my version, which I think, in my opinion, is well, it's pretty decent. I don't know if you've looked at it.
I just took a very short look on it, but maybe you can put the link into the chat so
Oh,
that
yes,
everyone
sure.
can look into it.
Yeah, or if you want to share your screen and walk us through it, I think that would be good.
Oh, yes, okay.
A quick question: when you crafted this together, did you use any existing GPIO API as a model?
At first, I looked at the embedded Hall traits to have like an overview of what is required. But then I looked at how Arduino did it and some other low-level APIs like the ones for the ESP boards. And I thought that was maybe a little bit better, less verbose and less mental overhead for the developer. So it's based on that.
Okay, cool. Thank you. Do I have to make you a presenter to share?
I think I can. I'm just looking at.
Oh, good. Okay, perfect.
Okay. So this is the API I made. There is like a general interface just to have less of the code duplicated for the errors and a pin number. I chose U8 because Arduino and other REST crates use U8 as well, but I don't know if there are any boards with more than 255 GPIO pins, so maybe that can be expanded to U16. And then there's the digital interface. So I've made a digital interface and an analog interface to separate them because they're both like they have different functionalities. For the digital interface, there is the digital output pin resource, which just acts as an output pin which can be set high or low or can be toggled. Then there's the digital in pin, which can read the state of the pin that's been acted on, and also has a few wait functions. They're like I try to represent interrupts kind of with this, but the code will just halt until a certain state is reached. Then to constructors for the pins themselves, they can be used. So if the pins are allowed to be switched between input or output, they can both be used with the same pin number, and then the previous resource that was acquired will just be invalidated. That's why there is quite a lot of different errors here. And lastly, then the analog interface, which is just the translation of the digital one to the analog world with the PWM, and the analog to digital converter, but basically the same functions, but for analog.
Maybe I can also give a little bit of context. This is the proposal that we also submitted to talk about in the call on Thursday. To talk about we want to basically standardize GPIO interface. Jarno is a master's thesis student who's doing his master's thesis about this specific interface. Michiel and me, who are in this call, We both work at Ghent University and at IMEC in Belgium, a research hub. And we want to continue this interface after Jarno's master's thesis stops. This specific interface, there is an abandoned proposal for a digital I/O interface in WASI, which I think this is the interface that we want to take over, become champions for that specific interface, but then probably change the name of that interface to GPIO instead of digital I/O, because we want to support both digital I/O over these pins and analog I/O over these pins. And so yeah, we're showing the interface here to see if anyone has any feedback. I know for the I2C interface, Max gave a lot of very good feedback about the size of data types and things like that. And so we want to get feedback here also. And maybe also if you have any feedback on the idea of taking over the digital I/O interface and then turning it into a GPIO interface that supports both digital and analog pin management. Yeah, any feedback is welcome.
Yeah, so from my perspective, as far as I know, we are in fact not using that much GPIO connection as of now, as we are so to interact with yeah, kind of, let's say, sensors and actors. We're using industrial buses, kind of like Profinet, as you might know. So this is, but it's more about communication. And when we're looking at the modules itself, it's kind of SPI, for example, and not that often GPIO in that regard. So there's not much feedback I could give yet, but that might change in future.
Okay,
Hi,
thank you.
hi, this is Max. I'm sorry, I have to leave very soon, but I think there are some products, at least as far as I know, that use actually GPIO, especially the analog part. Yeah, but I think I will just try and go through the proposal again offline, and then I can provide some feedback, because I think I have your email, or I know that I have it.
Okay, thank you, Max.
Yeah, you're welcome.
Yeah, thank you, Jarno and Merlin, for this. So a lot of good work here. I will review this as well. Your timing is good. We are actually building a GPIO interface at the moment right now at Atom. So it's it was I actually laughed when I saw the pull request come through. I was like, wow, it's so somebody must be aligned with what we're doing. One thing that there's two things I would propose for discussion. One thing I've seen with some of these is, so actually, first off, Merlin, you asked about, should we rename Digital IO, take this over and be GPIO? I would be fully supportive of that. I think GPIO is a concept most people know. It's a concept that's used very, very often. Even now on PCs, you'll see GPIO drivers listed. So I think moving this over and being champions of that, I think it's exactly what we want in the embedded SIG, for people to be champions of this and move these things forward. So I would be fully in support of this. Regarding technical feedback on this, there's two things I would say. First, one common pattern I've seen, and something we're trying to struggle with as well, is oftentimes I've seen some sort of configuration value set on the pin to indicate, is this active high or active low? And then from the GPIO perspective, it's either signaled or not signaled. And you don't have to worry about, was the signal high or was the signal low? Okay. And so that allows you to put all your crazy logic up front about how the pin itself is configured in hardware, but then allows your software later on to be more generic, right? I don't have to worry about do I have to set it high? Do I have to set it low? I just have to set signal, right? And so you don't get rid of the complexity, you just move it to the configuration step, which I think is where we're leaning towards. Obviously either works, but the other one requires you to manage that a little bit more. So that's something I would encourage to take a peek at. The other thing, the blocking calls, those are interesting, and might be required, might be needed. I think what happens a lot though is having some sort of using a GPIO for some sort of interrupt. Thomas, you mentioned you use a lot of SPI. I have a board sitting on my desk here that is a SPI Ethernet. And so everything happens through the SPI, except when a packet arrives. It needs an interrupt line for that. And for that, we configure a GPIO pin. And so I think that's actually a common practice where like, hey, either a button or some other device says, hey, I got something to do, and I need to signal that. Generally, those happen with callbacks versus a blocking call. Yes, you could do it with a blocking call and a thread, but we don't always have that luxury in some cases. And sometimes you just want something simple. Call me when that thing happens. Now, obviously, these are not ISRs at this level. This is probably a software callback. So it's more akin to a signal versus a true interrupt. But some way to register, say, hey, run this function or call this or set, call this function with foo, whatever that might be when that happens, I think would be a useful interface. Useful in this interface. The last thing I'll say, which is related to this, but probably a more generic issue, is how do I discover what the PIN number is, right? One of the things that we're doing right now, and I wouldn't say it's the best solution, is we're based on Zephyr, but Linux has this as well. Device tree has labels, and so I'm able to look up by a label a particular ID, and so I can get the PIN from that label. But trying to figure out how we map to like LED 0, for example, to GPIO pin foo. That's something I think we'll need to solve. I don't know if this is the right interface to do this. It's probably more of a generic, hardware platform interface. So that's why I don't think that's specific feedback to this proposal, but it's something to consider as well. So anyway, that's my thoughts.
Thank you for the feedback.
Very good feedback. So first about the blocking calls. This is not something that we expect to be part of the interface once it's actually standardized. It's just a test that we added right now in order to be able to show some behavior on responding to basically signals. I'm not super familiar with how multi-threading will work, how async the interfaces will work. And so because of that, probably that will be how we handle these things in the future. And I expect the blocking call to be gone before we actually standardize the interface itself. But if you have any idea of how this would interact with the maybe the threading proposal or the async proposal, I'm very interested to hear that. Maybe I should just read up on what the current proposals are to see how we would be able to do this. And yeah, how do you discover what the PIN number is? That's a very good question that I've also been thinking about. We might be able to add the functionality to request a label instead of requesting a certain PIN. If that happens on a system where pins are not labeled, then I would assume that we could just return an error, as if a pin with that label just didn't exist. And another approach that we've talked about was to just have like the main function of the component receive the pins that this component needs. And so then the runtime itself, once it starts the component or once it starts the module, it just gives you already the pins that this component is expected to need. But in some sense, then we're just pushing the problem to the runtime of like, how does the runtime know which pins this module actually needs? So I'm not entirely sure if that's the right approach. I would much rather have the approach where the application itself, the module itself, can tell the runtime which specific pins it requires.
You could maybe also extrapolate it, not talking about pins, but talking about semantics, and then you have the connection to kind of, in very roughly thinking, the web of things, right? So you have an application and it needs a temperature sensor, and you do not even care if it's connected via GPIO or I2C or SPI or whatsoever. So you just want to interact with the temperature sensor, and then you have to deploy it on a device where you can have access a specific temperature sensor. It's not a generic one, but it's a specific that senses maybe the temperature of a room or of a liquid in a tank, or don't know what, right? And there you're talking about very different things than a PIN number or address. You also do not talk about some communication protocols. You talk about a semantical kind of thing. And this question also holds in general very independent which protocol is under the hood. So I have to say, Stephen, you're right. This kind of mapping information, you called it an LED 0, is on GPIO pin, don't know what, 42 or whatsoever. Is important, but it's a configuration kind of thing. And if you think it further on, it boils down to kind of, where do I state which kind of semantical information from the outside world does an application want to have, which does it need? And there are also things kick in like, I want to sample it every, let's say, 150 milliseconds. Temperature is changing quite slowly, so 150 milliseconds is way enough, kind of. But then you can say, okay, the WebAssembly app is not allowed to be executed in Australia, while the sensor to be sampled is in Canada, kind of, right? So the deployment then says, okay, it must be closer to the sensor, and it must be a temperature, and this holds for a lot of things. So I think that this questions open up a totally different discussion at the end of the day. But I find it very, very interesting.
Yeah, Thomas, our approach is somewhat similar to that, and we're using labels because they're a simple concept, and we're sort of pushing the problem elsewhere. To Merlin's point, our application describes what labels it needs. We don't put any sort of semantics around how those labels should, or syntax around how those labels should be formulated. We sort of leave that up to whoever's building the system, right? So if you want to call it temperature sensor, that's probably too generic, right? You're more likely to have like, CPU core temp, right? Might be the name of your label. And so the application would ask for something by label, and then so that's how the application describes what it needs, right? It uses those labels. And on the platform side, we say, hey, that's up to the platform to wire the appropriate physical sensor to the appropriate label, right? And so there's two dependencies that we're solving. So we've just pushed that to the various different parts. So the person writing the application, he's concerned with what are the information I need and what labels do I need to ask for? And the person providing the platform has some labels to fulfill and physical hardware to wire those up. That's our approach. I'm not saying that's the right approach, but that's the approach we've taken. I think it balances a fair amount of simplicity versus it balances simplicity and utility. I've seen other things. I've actually spent a lot of time when I was on the Windows team working on the plug and play system, and there's all sorts of rich APIs for detecting and walking through the tree of devices and what device types and compatibility IDs, hardware IDs. And while that is interesting and good, it's also super hard and confusing to understand. And the complexity there is off the chart. So we opted to take something a little bit simpler. But again, that logic has to be done somewhere. So in our world, somebody has to map those properly on the hardware side. Anyway, just some thoughts.
I also want to add that we have a very similar issue for USB, for the USB standard that we're building. There we're running USB device drivers inside of WebAssembly, but then the challenge is, how does the runtime know what USB device a certain module expects at the other end of that USB interface? How we do it right now is that we like USB has this kind of enumeration walking through the tree of devices connected to a bus, and we support all this, and so the device can just request to get a handle for a specific device, and we don't have any security mechanisms built in, so it just receives that handle once it requests it, and it's able to use the USB. I'm not sure how it's called, but like the USB equivalent of the device tree, in order to figure out which specific device it needs. But it would be a lot more useful if we had some way for statically describing in a WebAssembly module or a WebAssembly component what specific USB devices it supports. Because then, first of all, we could much more easily do security based on least privileges. If a device says that it only supports, if a component says that it only supports a certain device, then it does need access to the other devices. And then we could also have more auto-plugging functionality, where a runtime can see that the USB device is plugged into the device. It checks the which USB device it is, and then goes into a registry to find if there are drivers for that specific device, something like that. Yes, Christoph.
I feel that this is something which would be neatly solved by the component model. And just seeing the component model, so a component model description shared on the screen. So just this deciding at runtime which specific hardware implementation to load is something which really reminds me a lot of basically composing a specific application for a target architecture.
So yes, component model gives us the first layer. But the interfaces of the component model, for USB, for example, that would just be the component describing that it uses the USB interface.
Yep.
But there's no way to give additional metadata to that interface of like, okay, I support a USB interface, and behind that interface, I expect these properties to hold true, which for the case of USB would be, behind this USB interface is this specific device with this vendor string or whatever. One of the approaches to remain in the component model is then to create a separate interface for each device. But then we have a proliferation of interfaces, and how do you do wildcards? How do you do, that would become very complicated. And then how do you do that at the runtime side? How do you ensure that new devices can still be connected to by old runtimes that were developed and deployed long before that device was released on the market? So I think from my perspective, we might need something a way to give additional metadata to a certain interface that the component says, I implement this interface with this additional metadata that then describes, for example, what devices it expects behind this interface. And this might also be something useful for file system access. To say like, okay, I support just file system IO, but I expect this specific file to be behind that.
This
I
probably
think-
brings, yeah, sorry.
I was gonna say, I think there's two issues you have, particularly with USB. You have like what is attached to what and what's that relationship, and that's generally a physical wired relationship. And then you have a logical relationship of like, what does that thing do, right? And you could have a temperature sensor. One could be on port 1 down some hub tree, and then you can have another temperature sensor, exact same vendor ID and HID ID and all this other fun stuff, but on a different port. And both of those, might be different temperature sensors, for example. One could be the CPU and one could be the output fan, right? And obviously they're not equivalent, even though they're both of the same sensor or device type, right? So there's a couple of different things you have to solve for, and I think the component model solves for some of that, but I think to your point, Marlon, there's a few other things that we need to get hints on for that. And as a reference, anybody who's looked at any of the PC specs for server chassis management, like the BMCs, there's a whole bunch. It's been a long time since I've delved deep into the firmware guts, but there's a whole bunch of identifiers for how, because obviously you have things like fans and temperature sensors, right? All over a modern server. But like input temperature, input air temperature, and output air temperature are very important and distinct things you want to manage differently. And if you get that wrong, you can screw up your hardware. And so they have a way to encode all of that. It may be something that we can look at for inspiration. I am always a fan of, if somebody has thought for this and come up with a really clever solution, let's reuse that rather than reinvent the wheel. Sorry, Christoph, you had something else to say. I think I touched you off a little.
Yeah, basically, so if you really go for it, so one of the promises of the component model is that you can basically implement interfaces. Yeah, basically you can compose them and implement them at runtime for different hardware. So basically you compose your application when going for a specific hardware. So that's quite neat. But on the other hand, I know that you cannot implement an interface multiple times. So that is a limitation of the current implementation of the component model. And we ran into it already in the past. So there's some limitations, but nevertheless, I feel if it goes to hardware abstraction, just providing an internal temperature sensor and an external temperature sensor as an interface makes perfect sense to me, and then just linking to a specific implementation, which then would be hardware specific and then would also probably route to the right USB or SPI or whatever interface internally. It just feels like a very natural abstraction layer, which they then can perfectly either simulate or so basically this is what the component model was made for.
Yeah, I think you bring up a good point about, you said simulation. I think another really interesting thing about this is if this interface is done correctly, you can use it for test and simulation, right? Yep. Which makes this a lot easier to do. As we all know, in the embedded space, testing this stuff is so much fun when you have to do it in hardware. On the blocking calls, one thing I would encourage you to do is just put a note on the top of that, just saying, hey, this is temporary. We're doing this as blocking calls today because we're waiting to see where, async and callbacks come in the component model. That'll just help people who see this who see just your spec without hearing or being on this call can better understand the context and be like, hey, wait a minute, why'd you do blocking calls? Like, we don't do blocking calls. We don't like blocking. It's like, oh, no, okay, it's a temporary thing. It's here. We acknowledge it. That'll just avoid some confusion from folks. I think you bring up a good point, though. How do we handle things like callbacks and software signals? I think that's something that needs to be addressed. And I don't know if you have any thoughts on that, Christoph, as
Yeah,
to how
I
that's
do.
best handled here. Okay.
The best solution I know up so far is basically using WASI 0.3, so futures and streams. And yeah, I know the pain, and I feel that this is actually a very good abstraction because it enables, yeah, instead of using the sorry, there was an implementation for 0.2, which is so the weightables. You can really go for multiple tasks and all these things. And yeah, I'm personally, having used 0.3, I really feel this is the way to go, and this unlocks so many ways there. So yeah, even though it's not yet published, I feel, yeah, this is definitely worth taking a look at, and this will solve so many limitations of the current system, especially when it comes to asynchronous handling of yeah, of course. If you go for a different language than Rust, for example, C or C++, you have the additional problem that you cannot really do this without proper compiler support, which is C++ 20 onwards, or yeah, having multiple threads, which then, of course, runs into the territory of the problem of shared everything threads, which is also in the process of currently being stabilized. So yeah.
So just so I understand that correctly, 0.3 futures async requires C++ 20 support?
It does not. But if you really want to go for waiting for things in, the problem of ideally you would actually do a future then, which means you basically do continuation. And C++ is the only language where that one is not standardized really. So that requires C++ 20 onwards by using co-await and similar things. So it's really the languages which has trouble there.
Oh, because they don't have like I'm familiar with C# in this and
Yep.
Go. So like things like async await and capturing the context and all that fun stuff. Okay, so the C++ 20 provides that. Okay. Yeah, because my question to you on that is, has any thought been done in 0.3 around this about running multiple threads in the same WASI module at the same time?
Yes, this is basically stack pausing and stack continuation. So it's not basically it's not a thread within the it's basically a runtime operated thread. So that would be there's also task primitives, which is not the same as a thread, of course, but task primitives which are also standardized in 0.3. And so if you really want to go for stack stopping and waiting for a specific signal and continuing with stacks and stack switching, task switching, this is also included in 0.3.
Okay. And does that change does that require any core WASM changes? Or is that just all in component model?
I think stack switching is still a proposal. So you need the stack switching proposal. Which
and
really means that, yeah.
That's core WASM, stack switching. Right?
Yes, exactly.
Okay.
Or some other way of implementing it, but basically implementing the proposal is probably the easiest way to go there.
Okay.
If I recall correctly, there were at least 2 stack switching proposals. On which does it rely on the one from, I guess, University of Edinburgh, or from Thomas Lively, Google?
Oh,
No,
I will need to figure
sure.
out, but I don't have an answer offhand. But
okay. Hmm?
Good. Any other thoughts, questions on this? No, we got only a few more minutes left.
Maybe I can just give a short comment about the component model. So for the interfaces that we're developing, we always develop the interfaces themselves in WIT. And it's very easy to write the first implementation of the backend then as a WASM time host component. It's a very useful API to start and work on this. And then it's a lot more difficult to implement it in WAMR without having the support structures of the components model. And then for the workloads that we're focusing on, things like USB device drivers, in terms of latency overhead and CPU overhead, it seems like the component model isn't really a big challenge for us. But we do see the increase in memory overhead of the component model. And so I would be very happy if we could find a way to also use these like things like WIT for embedded development. But I'll leave figuring out how to do that and how to solve the memory overhead issues and stuff like that. I'll leave that to people more knowledgeable than me in these specific things.
I feel the shared everything implementation of the component model, which I just presented, WASMCon, might be a good candidate, especially if combined with plugin loading, for example, the shared library proposal, which would give you basically the ability to run to load additional modules at runtime. But that of course needs proper relocation support. So basically shared memory, shared library as a compilation target.
So what has been discussed a few times, thanks, Christoph. I think what has been discussed a few times is, what sort of tooling improvements could be made to allow us to address this. Even if we didn't do it dynamically, could you do some pre-processing on a bunch of components or component interfaces, and get the output you want, where all those modules are somehow linked together, and the interface is either wrapped or unwrapped, so they can run on a non-component model runtime, for example, enabled runtime, for example. So there's been talk about a few things that could be done there, and how do we get there and close that. And so I think I'm with you, Merlin. I think there needs to be a way to be able to describe these things in a language like WIT, and then be able to generate those bindings properly, whether you're targeting the component model or not. So I think that I view that, at least my opinion, is that's probably 70% of a tooling issue at the moment. I don't think we have the answers as to what those tools should do, which is the other part of probably the stickier bit. But I think some of that can be addressed with tooling.
Yeah, it's good to know that it worked pretty well with the WASM time and with the tooling. That's good to know. Good to hear. Have to admit that. I would be curious about data points if you have some, especially so when you implement it for GPIO and use it. Also, how it scales, if it's just not 3 or 4 GPIO pins, but maybe, don't know, tens, hundreds, kind of. How it scales then, and would be very cool if we have some data points on it when using WASM time in that regard. That would be great.
For USB, we have a preprint available where we have a bunch of performance, where we did a bunch of performance analysis. But I don't think we have them for the more lower level interfaces. I'm looking at Michiel, who's in the call here, who wrote that paper.
No, it's only for I2C and USB at the moment.
Yeah, basically it's about the difference between the approaches, right? So if you say you have a big effort for WAMR, granted, right? But if you then compare the performance impact, then it would be nice to have some comparable figures regarding this is with lesson time using the component model, and this is with a lot of effort, a lot of pain with WAMR. These are the performance figures you could get out of it. That would be great. And in that regard, it also is not that important whether GPIO or SPI or USB, and it's also not about the absolute numbers. It's just the relationship between those, right? To see the differences between them, and maybe also see the difference between just do it natively, right? That would be awesome if you get it.
I don't disagree fully. Although one thing I will say is it's more of a caution than a disagreement. Is, you know, when you're dealing with things that are running on PC class hardware, modern processors do all sorts of crazy things, right? There's lots of registers in a PC based system, and one thing that I've noticed is running benchmarks on WAMR on x86, x64, and then running those same things on an ARM Cortex M, even a fast one. The delta is very, very different, right? Because you're dealing with very, 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 very different processors and very different characteristics. And so what is easy and somewhat fast on you know, an Intel processor with lots of registers and lots of L2 and L3 cache suddenly becomes very, very different on a Cortex M. So I'm interested in seeing those numbers because I think those are useful. But I think especially with multi-threaded processors and the way complex processors like x64 actually execute can mask a lot of potential performance issues that could be problems on simpler CPU architectures. So not an invalid test, but something to consider when we're looking at those numbers.
Definitely, we already encountered those issues, right? Also with pressure on the cache lines. We also have seen that. All these very nasty kind of things that might come up. So it's very, in either way, if you do those benchmarks, you need to be very careful and in keeping the comparability of the results, right? It does not make sense to compare apples with peaches. That's for sure, and this is a very hard thing. And if you publish those numbers, be very serious in making this data bulletproof in the sense of comparability.
Yeah, I mean, I think they're absolutely valuable comparisons. I'm not at all recommending we shouldn't do it. I just think we just need to be careful when we're extrapolating performance numbers, you know, to say, hey, there's a 2% overhead in doing it this way. That might be a 2% overhead on a x64 superscalar processor, where it might be a 25% overhead on a simple Cortex microcontroller, right? So just, you know, kind of beware of those things. That's all. We are at time. Any other questions before we close for today? This is good. I'm assuming people can reach out to you, Jarno, directly if they have questions.
Yes, they can. And I want to say, oh, can you hear me?
Yes.
Okay. I want to say I'm extremely thankful for all the feedback. It was a really mind-opening.
Good. Well, thanks for the hard work.
Thank you.
All right. I'll close the call unless there's any other issues, and then we'll see you on the next one. Okay. Thanks, everyone. Have a good week.